All right, let's take a look at the Chapter 5 kind of skill check area. I'm just going to kind of walk through some of these things to make sure that you have an explanation to go with some of those results. Some of it's primarily review, so remember when we're taking a look at these things, always think back to your algebra studies of y equals mx plus b, and then remember, usually just to make things more difficult when we are talking about it in statistics, they might use something like y equals a plus bx. Again, the idea about the slope and the intercept is where a lot of these things are based on finding the intercept, specifically the y-intercept and the slope. All right, so the first problem, it talks about the slope of this figure in 5.9. Well, taking a look at this, remember slope really is the change in y over the change in x, so rise over run. So when I'm looking at this, what I'm comparing is just saying like from right about here, and I'm looking at where 50 is. So I'm going to say 50 is right about here, and I am going to go up to wherever this 60 is, just so that I'm going up 10. All right, so here's positive 10. And then I'm really looking at how far over did I go. So this is again approximately, so that's maybe 96 to approximately 111. So from 96 to 111, we'll just round these off, 95 to 110, so 15. So I went up 10 and over 15. It wants to know if this slope is closer to 1, 0, or negative 1. Well, really I can tell right away that this is positive because of the direction it's headed. So it's either going to be closer to 1 or 0. And looking at this, if I were to simplify this, you should hopefully recognize that, put it in here, it's like 2/3. 2/3 is a little bit closer to 1 than it is to 0. So my suggestion for that one is that this one is going to be closer to 1. So letter C as you're taking a look at it. The next few problems all have to do with this equation. Or no, just the next one. Y equals 4 minus 3x. And I'll put the number up here just in case people are looking for it in the YouTube video. So this is 519, and it asks us what the slope of this line is. So again, slope is not, even though a lot of times in algebra we thought of it like this, slope is not just the first number, it's positional. It's the coefficient of x. So it means it's the number in front of x. All right, so 520 says Fred keeps his money in a mattress. He begins with $500 and adds $100 each year. So it wants to know about his total savings, Y, after X years. So Y is how much he saved. X is each year, so that's kind of like this. So when I'm adding this up, it seems pretty obvious to me that you start with $500 and you're going to add $100 each year, means you multiply that. That is going to be the equation that matches it. Just to show you, so this is letter A for this one, to show you or at least talk through some of these other ones, if I had Y equals 100 plus 500x, that means I'm earning $500 each year, and I'm adding that to $100 that I started with. If I have this, Y equals 500 plus X, that means I'm just adding $500 to whatever the number of the year is. If I work for 3 years, I'd make $503. And that's kind of a weird pay scale. Basically, it means since there is no number there, it means I make $1 per year, $1 times X. So that's the 520. 521 talks about smokers and kind of talking about the comparison to, it basically says a regression line. It says you regress the age at death based on the number of packs of cigarettes. And notice when I talked about that, it's like, here's my age at death. I'm going to make that y, and this is going to be my x. X is usually our explanatory variable. So I'm using the number of packs that you smoke to explain how old you are when you die. And they say in this example, and so here I'm not going to put numbers on it, but here is how many years you live. So this is age, and this is packs. And they're basically saying in this that people who smoke 0 packs of cigarettes a day are going to live this long on average. And they're basically saying that the more packs you smoke per day, the less you're going to live and whatnot. So here's some data for those points. Hopefully you're recognizing that according to the way this is talked about, we're going to have a line that looks this way. I don't know exactly what the slope of this line is, but they're asking basically, is the slope, is it going to be 0? Is it going to be less than 0? Or is it going to be greater than 0? This is a negative slope, so it's going to be less than 0. In this case, it's going to be choice B. So that was 521. All right, 522, a couple people had asked in class, and I actually got this one wrong, and I thought about it more. It gives you an a prediction of whatever this stands for, 6.4 plus 0.93x. It says, here's the measurements of young children in Mumbai, and the least squares line for it predicting height. That's going to be the height prediction based on your arm span. So height and arm span. And then it goes on to ask in this question, let me find, I have to scroll down a little bit over here. It says, for 22, it says, according to this, measurements in centimeters, how much on average does height increase from each additional centimeter of arm span? So this is saying I start at about 6.4 centimeters, and I'm adding this much per each inch or per each centimeter. So this 0.93, the slope, letter A, is going to be the correct choice for that, how much you're adding each time. A lot of people will pick 6.4, but remember, that's the baseline. If you had no arm span, you'd apparently be 6.4 centimeters tall. So it probably doesn't work to have a 0 as an arm span. You have to have something there, but you're going to keep adding 0.93 centimeters every time you add 1 centimeter of arm span. You're going to add 0.93 centimeters of what's going on there. So that's kind of the whole idea of slope. So that's 522. 523, this is the one that I got wrong. It's, 524 I got wrong. So according to this regression, the predicted height of a child with an arm span of 100 centimeters. So if my predicted arm span is 100 centimeters, or a child in there, I'm going to put that in and just say 6.4 plus 100 times 0.93 ends up being 6.4 plus 93, so 97.4, or 99.4 centimeters. So choice B. All right, so finally, the one that I was getting wrong, it says, by looking at the equation of this least squares regression line, it wants us to know or talk about the correlation. Well, I was describing to a few people in class that you can't figure out the correlation based just on this, but I didn't look close enough at the results. I do know that the slope is going to be positive. I know that the correlation is also going to be positive. I don't know how close to 1 it's going to be, but I know it's going to be positive. Remember, positive slopes and correlations are going to be like this. Negative slopes are going to be like this. 0 is going to be flat. I know this has a positive slope. So I know the correlation is going to be positive. So for 524, I know for a fact that it's going to be A. All right, so same equation. Write that down again. Arm span and height. It says, the report says that the actual measurement of this, the r squared, the thing that explains the variation, is 0.95. And it says, when you talk about r squared, I know there's variation. I know there's data everywhere. All right. R squared says that 95% of the variation is explained by this model, by the model, and here's our model, that model right there. So what that tells me, 95% of it, that tells me that this model is going to pretty accurately represent the arm span or the height of someone. So really, I'm going to go ahead and say letter C for that. So what is this, 525? Yeah, letter C is the one that says prediction of height from arm span will be quite accurate. And it's based on that. Keep in mind, too, that this does allow me to calculate what R is. The correlation would be the square root of 0.95, and you can calculate that value in order to see what that tells you. So that's 525. 526. Says, because elderly people have many different may have difficulty standing to have their heights measured, a study looked at predicting overall height from height to the knee. So they're measuring from the ground to the height of your knee, and they give some of the data in there. They give like 57.7 is the height to the knee, and the actual height is 192.1. All right. The next one, 47.4 and 153.3. Says, use your calculator or software. What is the equation of the least squares regression line? So remember, when we're doing that, we want to be able to, and this is one of the key things for there, we want to be able to use software to do it. So let me jump over height to the knee, and we'll go into just a Google document. So typically when you do this, you need to have your X and Y. So I'm just going to throw these in here. So here's X. And just so that I have it, X is height to knee, and Y is total height. All right, so X and Y, 57.7 corresponds to 192.1, 47.4, these are off, so let me move you guys down where you need to be. And you. All right, so I think I got those ones there. There's a couple of ways to do it. I'm going to show you the shortcut for it. They just want the equation. So I am going to, I need to know the slope of the y data, comma, x data. And I want to know the intercept equals intercept. Again, y data, comma, x data. And so that seems to tell me that my slope is going to be, y is going to equal 44 plus 2.4x. That's basically slope and intercept. And that matches, looks like letter B in the case here, and I will double check that it does. 2.4x plus 44.1, yep, so letter B, y equals 2.4x x plus 44. And I wrote it in a different order than is in the book, but that's the result for letter B. All right, so those are the questions that we had in kind of that skill checkup. Really, most of it being able to explain or being able to identify the slope, the intercept, understand what that means about the trend line, as well as be able to use software to figure that out. And finally, the last thing, I suppose, when you're doing this, the other things that you should be able to find here is finding the average of all of your x's like we've done before, as well as finding the standard deviation. So you can do that without too much trouble. You can also use the descriptive statistics in order to do that as well, or the trend line that is kind of covered in those previous videos. So hopefully that gives you a little bit more to go on for evaluating how you did on that skill checkup.